find the volume bounded by the surfaces z is equals to a square minus x square and the planes x equal to 0, y equal to 0, z equal to 0 and y is equals to b. Now, clearly we can say that z varies from 0 to a square minus x square, as the value of z is 0 as well as a square minus x square. Now, if z is 0, then x varies from 0 to a. If I substitute z as 0 in a square minus x square, it varies from 0 to a, as x is given as 0 here, and if I substitute, x will be a. Now, similarly, y varies from 0 to b. Now we have to find the volume integral, so I'll take the limits as x is equals to 0 to a, y is equals to 0 to b, as well as z from 0 to a square minus x square into dz dy dx, as it is volume integral. So it is nothing but, as x is 0, it starts from 0 to, it is nothing but a, then similarly 0 to b, then similarly 0 to a square minus x square into dz dy dx. If I differentiate, if I integrate it, it will be dz is nothing but z, and z is varying from 0 to a square minus x square. So if I simplify, it will be a square minus x square to dy dx. Now, similarly, if I integrate further, a square minus x square both are constants because integrating with respect to y. So it will be a square y minus x square y over the limit 0 to b into dx. And if I simplify, it will be nothing but 0 to a, b times of a square minus x square into dx. And this is nothing but b times of a into, integration is x, integration of constant. Similarly here, x cubed by 3 from the limit 0 to a. If I simplify, it will be 2 by 3 times of b a cube, which is nothing but option B. The given function is u is equals to e power x, y, z, and we have to find dou u by dou x, dou y, dou z. Let us start with z. Differentiating the given function partially with respect to z. So it is nothing but dou u by dou z, which is nothing but e power x, y, z. The reason is differentiation of e power x is again e power x. As we are differentiating partially with respect to z, x and y are constants. So the differentiation of z is 1 and the constants are x and y. So the function will be xy into e power xy z, which can be written as dou u by dou z as u into xy. Now let us differentiate this dou u by dou z with respect to y. So it will be dou u by dou y into dou z, which is nothing but ux plus xy into dou u by dou y, which is nothing but ux plus ux square yz. The reason is we are differentiating u with respect to y. So u and y will be the variables and x is a constant. So keep ux as it is and differentiation of y is nothing but 1. So xy into differentiation of u is nothing but dou u by dou y, and dou u by dou y is nothing but uxz, as y is a variable. Now similarly we'll differentiate this function with respect to x. So dou x, dou y, dou z, and if we simplify, answer will be e power xyz into 1 plus 3xyz plus x square y square z square, which is nothing but option D. It is given that trace of matrix A is 20, whereas trace of matrix B is minus 8. We have to check the trace of A plus B. Now we know that trace of A plus B is nothing but trace of A plus trace of B. So which is nothing but 12. That is option C. The given differential equation is dy by dx is equals to 1 plus y square, which can be written as dy by 1 plus y square is equals to dx. If I integrate on both sides, it will be tan inverse y is equals to x. That implies y is equals to tan x, or I can take constant anywhere, so plus c. So it will be y is equals to tan of x plus c, which is nothing but option C.
Horizontal force P necessary to push the 100 Newton roller in figure over the 5 cm obstruction. Assume the roller is smooth. So here is the given diagram. Here the roller is pushed by a force of P over a obstruction of 5 cm height. Here the roller's radius is 440 cm, and here the given options are 22.1 Newton, 33.2 Newton, 44.3 Newton and 55.4 Newton. So here coming to the solution, first consider the free body diagram of the given problem. So for the free body diagram of the roller is like this. First one is, we'll have to consider the weight of the roller, and there is a pushing force of P in horizontal direction, and there is no reaction at the ground floor because it starts moving at the point of application. So that, but there is a reaction at the corner point where it has to move over the obstruction. So this is the normal reaction at the edge, so which is at some angle. So here the distance from the central axis is 35 centimeters, where obstruction is 5 centimeters and radius is 40 centimeters. Okay, this is the given free body diagram, and here it is a force of 100 Newton. 100 Newton. Okay, now first find out the angle subtended by the normal reaction. So here let us say it is making an angle theta with the horizontal. So here sin theta is equal to opposite side by adjacent side. Here opposite side is equal to 35 centimeter and adjacent side is nothing but the radius of the roller, that is equal to 40. From this we can get here theta is equal 61 degrees. Now consider all the reactions at a point. So here is 100 Newton, and here is a force P and a reaction N which is making an angle theta, that is 61 degrees with the horizontal direction or with the P. Okay, now consider sigma H is equal to 0, that is sum of the all horizontal forces are equal to 0, and sigma V is equal to 0. First consider sigma H is equal to 0. From this we can get here P minus N cos theta is equal to 0, and from the sigma V is equal to 0 we can have 100 minus N sin theta is equal to 0. So from this equation we can get the value of N, that is 100 by sin theta, which is equal to a value of 114.3 Newton. Now we can calculate the P, which is equal to N cos theta, that is 114.3 into cos 61, which gives a value of 55.4 Newton. So here the required push is 55.4 Newton, and in the option the correct option is D. D is the right answer.